Good morning, ma'am. Myself Venu. I am from CSCF section. Today I am going to explain about the directional derivative and angle between two surfaces. Introduction to directional derivative and surface angles. This presentation explores the concepts of directional derivatives and how to determine the angle between two surfaces. Understanding these topics is essential like vector calculus, physics and engineering. We will cover definitions, calculations and applications related to mathematical ideas. What is surface in multivariable calculus? A surface is a two-dimensional manifold emitted in a three-dimensional space. Surfaces can be described by equation of z is equals to f of x comma y. Understanding the geometry of surfaces helps in analyzing their slopes and intersections. The concept of gradient vector. The gradient vector points in the direction of minimum increase of the function. It is composed of practical derivatives. Nabl f is equals to left frac practical frac by fractal. This gradient is perpendicular to the level curves of the functional surface. Definition of directional derivative. The directional derivative measures the rate of change of The directional derivative measures the rate of change of a function in specific direction at a given point. It is calculated as d math by nebula dot math, where math b f of u is a unit vector in desired direction. The directional derivative generalizes the concept of slope to multivariables. Calculating the directional derivative. To compute it, first find the gradient vector at the point of interest. Next, determine the unit vector indicating the direction. Finally, take the dot product between the gradient and the unit vector to find the rate of change. Angle between two surfaces. The angle between two surfaces at a point can be found using their normal vectors. The normal vector to surface is given by gradient of its defining function. The angle theta between two surfaces cos theta. Fraction nebula f by c dot by nebula g by nabl f by nabl g. Calculating angle between two surfaces. Obtaining the gradient vector of both surfaces at the point of intersection. Compute the dot product of these two normal vectors. Divide the dot product by the product of their magnitudes and take the inverse cosine to find the angle. Application of directional derivative and surface angles. These concepts are crucial in optimizing functions subject to constraints in engineering. They are used to analyze the orientation and intersection of physical surfaces in physics. In computer graphics, they help in shading and retaining by understanding surface normals and angles. Summary and key takeaways. The directional derivative provides the rate of change of function in specific direction. The angle between two surfaces can be determined using their normal vectors derived from gradients. Both tools are fundamental for analyzing and intercepting multiple functions and surfaces. Questions and further readings. Feel free to ask questions to clarify any part of the presentation. For the further study, consult textbooks on multivariable calculus such as Sweet's Calculus. Additional resources include online tutorials and mathematical software for analyzing and derivatives.